In the previous morsel, we talked about the fact that the kernel and the user-level library don't have insight into each other's activities. And let's talk about that a little bit more now. At the kernel level, the kernel sees all of the kernel-level threads, the CPUs, and the kernel-level scheduler is the one that's making decisions. At the user-level library sees the user-level threads that are part of that process and the kernel-level threads that are assigned to that process. If the user-level threads and the kernel-level threads are using the one-to-one model, then every user-level thread will have a kernel-level thread associated with it. So the user-level library will also essentially see as many kernel-level threads, but it will be the kernel that will actually manage those. Even if it's not a one-to-one model, the user-level library can request that one of its user-level threads be bound to a kernel-level thread. This is similar of what we would want to perhaps do in a multi-CPU system if a particular kernel-level thread is to be permanently associated with a CPU, except in that case we call it thread pinning. And the term that was introduced with the Solaris threads was that a user-level thread is bound to a kernel-level thread. And clearly in a one-to-one model, every user-level thread is bound to a kernel-level thread. Now let's have this situation in which one of the user-level threads has a lock, and so that basically the kernel-level thread is now supporting the execution of that critical section code. Now let's say the kernel preempted this kernel-level thread from the CPU to schedule the other one. So that means that the execution of this user-level thread, the execution of this critical section cannot continue. As the user-level library scheduler cycles through the rest of the user-level threads, if they need the lock, none of them will be able to continue. So only after at the kernel level we schedule this thread again, will the critical section complete, the lock will be released, and so subsequently the rest of the user-level threads will be able to execute. So to reiterate this problem that there is lack of visibility between the kernel and the user-level thread management is because at the user level, the library makes scheduling decisions that the kernel is not aware of, and that will change the user to kernel level mappings. And also data structures like mutexes and wait queues, that's also invisible to the kernel. So the fact that this lack of visibility causes situations such as the one that we described really leads us to the conclusion that we should look at one-to-one models to address some of these issues. Since the user-level library plays such an important role in how the user-level threads are managed, we need to understand exactly when does it get involved in the execution loop. The user-level library is part of the user process, part of its address space, and occasionally the execution basically jumps to the appropriate program counter into this address space. There are multiple reasons why the control should be passed to the user-level library scheduler. A user-level thread may explicitly yield. A timer that's set by the user-level threading library may expire. Also, we jump into the user-level library scheduler whenever some kind of synchronization operation takes place. Like when we call a lock, clearly that thread may not be able to run if it needs to be blocked. When we call an unlock operation, then we need to evaluate what is the new runnable thread that the scheduler should allocate on the CPU. And in general, whenever we have a situation where a blocking user-level thread becomes runnable, we jump into the scheduler code. This is part of the library implementation. This is not something that you will explicitly see. In addition to being invoked on certain operations that are triggered by the user-level threads, the library scheduler is also triggered in response on certain events, certain signals that come either from timer or directly from the kernel. The next morsel should give you an illustration of these interactions.